5, counting principle. And you have to have a calculator to do this.
I have a calculator.
Good. Okay. The counting principle. So, let's say you place 8 pieces of paper numbered 1 to 8 in a box. And you draw one piece of paper at random from the box. Record its number and replace the paper in the box, okay? What's the chances that you will draw a 2 when you pull out a piece of paper from a box that has numbers 1 through 8? It is probability, yes.
How many numbers? What? How many numbers are there?
1 through 8.
You have
1 8. You would have 1 8. If I replace it, what's the chance that I would pull out a 2 again? Okay. So if you pull out a 2 the first time and you have a chance of 1 8, and you pull out a 2 the second time and you had a chance of 1 8, you actually pulling 2 2s in a row would be the probability of multiplying 1/8 by 1/8, which is 1/64. So to pull a 2 and a 2 back to back, it's only a 1 out of 64 chance of doing that. Okay? So you have to take the probability of event 1 and multiply it by the probability of event 2 to get the probability of those things happening consecutively. Does that make sense? Okay? So we're going to start looking into permutations of elements. Okay? A permutation means that when we are looking at something, order does not matter. Okay? An ordering of elements is called a permutation. So permutation is the ordering of elements. Now, on your calculator, you should be able to do permutations on yours, and combinations and all of that. I just have to figure out where it is on yours. My guess is it's under math. Yeah, it's under math and then the PRB, the probability, okay? And a permutation formula, or the one that we're going to use, is the NPR. Where N is the number, like your total number of what you're taking, okay? And R is like my rate or my placement. So if I say you have 1,000 people and they can take first, second, and third place, how many combinations of that can I have, or how many permutations of that can I have? Then you would put 1,000 P3, and it would tell you how many permutations you can make out of that. Also, do you guys remember from last year this symbol?
Yeah.
Okay, that means what? Yeah, an exclamation point. Okay, that is part of permutations. And so we are going to use that. If I had a permutation that said 8 like this, that means that I have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? That's why we're going to use that button over doing that, most likely. So, permutations of elements. Let's look at a couple problems. It says, how many permutations of the letters A, B, C, D, E, and F are possible? So you have A, B, C, D, E, F. How many permutations of that are possible? How many total letters are there? 6. So in the first space, how many letters could go there? 6. In the second space, how many letters could go there? 5. And then it's going to go 4, 3, 2, 1. Yes. So, if I want to write this out easier, it's just 6 explanation point. What do you get when you do that? 720.
Where is the next page?
Under math, and then under PRV, which stands for probability. Okay? So when you're looking at something like that, that's how you need to think of it. Okay? There are 720 combinations or permutations that you can make off of that permutations. Okay? Okay, let's talk about this. 8 horses are running in a race. In how many different ways can the horses come in first, second, and third? Okay? So you have 8 horses, and you want first, second, third. So how many ways can I have here? Well, yeah, it is 3 of 8 that we're looking for. But in the first place spot, how many of those 8 horses could come into first place? 8. Any of the 8 can come into first place. How many could come into second place? 7. How many could come into third? Okay. This type of permutation is what's represented by this here. In PR can be written as the number, okay, over the number minus the rate, like this. Meaning, if I have this up top, it means I have 8, 7, 6, 5, 4, 3, 2, 1. On bottom, I have 8, and there are 3 positions. So 8 minus 3 is 5, yes? So on bottom, I would have 5, 4, 3, 2, 1. Well, all of these cancel, leaving you with what we have there. 8 times 7 times 6. So if you plug into your calculator, if I change this, okay, and plug it into my calculator to say 8P3, what do you come out with? You would press 8, and then you would go to math, go over to probability, pick the one that says NPR, and then you press 3, and then you press enter. 336. You get 336, which is the exact same thing as multiplying 8 times 7 times 6 together. This too equals 336. So we can do this a quicker and an easier way. Does that make sense? Okay. So, okay. So let's talk about if we have, where did I get this 5 from? Because I did 8 for the n, because I have 8, minus 3, because I have 3 positions. 8 minus 3 is 5. Okay. Let's say, remember that permutations order is important. So to find the possible permutations of the letters A, B, C, and D, taken 3 at a time, you count the permutation A, B, D, and B, A, D as different because the order of the elements are different. So permutation order is important, and if they're in different orders, then they count as the second one, okay? Consider, however, the possible permutations of the letters A, B, C. So if I have the letters A, B, C, okay, what do you notice about those 4 letters? There's 2 A's, okay, which is important. The total number of permutations of the 4 letters would be this, 4P4, right? Because there's 4 total letters and this, which is the same as saying that, okay? However, not all of the arrangements would be distinguishable, okay? Because there are 2 A's. So we want to be able to distinguish between the A's here. If they swapped, it's still the same thing, yes? Okay? So because we can't distinguish them, we have to take that into consideration. To find the number of distinguishable permutations, you would use the following formula. And we would go something like this. the number over in 1 times in 2 times in 3, and so on and so forth until you get to the end of whatever that is. So, we're going to take a look at one of those. Let's say you have, okay, and how many distinguishable ways can the letters banana be written? So I have B, A, N, A, N, A. Okay. So in how many distinguishable ways can banana be written? Well, what goes on top is the easy part. How many total letters do we have? 6. 2, 4, 6. Okay. Now, on bottom, I've got to talk about everything that repeats or does not repeat. Okay. So I look, how many A's are there? 3. So you have this on bottom. 2 N's times 2 times 1 B. Okay. Now we can cancel some things out from there. Thank you, Ben. Okay. So we can cancel some things out from there. We can go like this. We know that 6 means that it's 6 times 5 times 4 times 3 times 2 times 1. Yes? So the 1's automatically can cancel out on the bottom, correct? Okay. That's an easy one. So 1 and 1 cancels. Here I have 2 times 1, correct? So the 2 would be like this. And I have a 3 times 1. Well, the 3 will cancel out because the 3 is the same as this. 3 times 2 times 1. Yes? Okay. So now I'm left with 6 times 5 times 4 up top, and then I'm left with 2 times 1 on the bottom. Okay. So my answer is going to be whatever 6 times 5 times 4 divided by 2 is. 6 times 5 times 4, and then divided by 2, and you should get 60. There are 60 different ways of distinguishable ways to rearrange the word banana. Okay? So when things repeat, you've got to look at that, and that's what you're dividing by is the repeating actions. Okay?
You confused me on that part.
Okay.
Why don't we just cancel out 3 through 1?
You can't. This stands for 3 times 2 times 1. This stands for 2 times 1. This stands for 1 times 1. The 1 doesn't make a difference. I don't even have to put it there anymore because it's stupid to divide by 1. You don't need to. Just because we have to. The other thing we're going to talk about is combinations. Combinations. And a combination and then we'll be done for today. A combination, okay, is a set in which order is not important. In our calculators, we can see combination written as NCR, okay, and that breaks down to this. Permutation of N over, okay, N minus R permutation times the permutation of R. Okay. So, in how many different ways can the letters be chosen from the letters A, B, C, D, and E? The order of the 3 letters is not important. So we're going to use A, B, C, D, and E. And the order does not matter. So how would I set that up? What? Yeah. It's 5, C. No, it says you can find in how many ways can 3 letters be chosen? 5, C, 3. which means if I rewrote it in this form, it would be the permutation of 5 over 5 minus 3 permutation times 3 permutation. So it's 5 permutation over 2 permutation times 3 permutation. Okay. Or you can plug it in your calculator and do 5C3, and what do you get? 10. Okay, and I get 10 because this is 5 times 4 times 3 times 2 times 1 up top. On bottom it's 2 times 1 times 3 times 1. 1, 1, 3, 3, 2, 2 cancels. Oh, I missed a 2, that's why I'm angry. And so then I get 5 times 4, which is 20, and 20 divided by 2, which is 10. Same thing. Okay. So yeah, so order matters. It's a permutation. Order does not matter. It is a combination, and everything pretty much can be done on your calculator. I do need to see this part written out though, so that I can see what you're plugging into your calculator for me. Otherwise, that